Okay, so lesson 4 in polynomials, factoring. We're going to start factoring. We've done a couple days here where we've done expanding. But today we're going to talk about our greatest common factor, and which is the first thing we talk about when we talk about factoring. So factoring is really talking about dividing, whereas before when we were doing FOIL and we were doing distribution, we're talking about multiplying. But when we're talking about factoring, we're really talking about dividing. So when dividing terms, the coefficients are divided and the exponents of the same variable are subtracted. So we still have to apply our exponent rules to apply for when we come to the variable terms, but the coefficients are going to be divided as normal. So if we look at this, we have 6 and 2, they're going to divide and give us 3. And with the exponents x to the m divided by x to the n, we'll use our exponent rules, x to the m minus n. Often m and n will be numbers, and we'll be dealing with that way. So you've got to think about your exponent rules when you're doing these, and remember that those don't apply to the coefficient. So remembering our exponent rules, if we're dividing with the same base, we subtract the exponents. So, and this says evaluate if necessary. So 2 to the 5th divided by 2 to the 3 would be 2 to the 5 minus 3, or 2 to the 2. And we can evaluate that. 2 times 2 equals 4. X to the 3 divided by x to the 4th, well, that would be x to the 3 minus 4. So that would be equal to x to the negative 1. Okay, we're not going to do much with negative exponents today, so we're going to leave it there. But in the future, we'll be doing different things with negative exponents. So in C, we have a coefficient and we have a variable. So the coefficient would be 49 divided by 7, so it would be 7. And a to the 4th divided by a to the 2, we would subtract those exponents and get a to the 2. Okay. Now here, 3 divided by 9, well, I can take a 3 out of the top and the bottom, so I can leave it as, I can leave it with just a 3 in the bottom, like a 1/3. Y to the negative 4 divided by y to the 1 would be y to the negative 5, because that's going to be negative 4 minus 1, which equals y to the negative 5. Okay, that one's a little trickier because of that the third. You could also change that if you wanted to. You could make it would be the same as having 1/3 y to the negative 5. Either way is still the right answer. I don't like those questions. It's being a little tricky there. Y to the 3 divided by z to the 2. Well, they don't have the same base, so you would just have to write that as y to the 3 over z to the 2. And that you can't simplify this any further. Okay? So sometimes that does happen. Okay? Now, that's just a little review of our exponent laws. Okay? We're factoring today, and it's important to know that factoring is the reverse or inverse operation of expanding. So, for example, if I'm expanding, I'm going to distribute. So here I have 2x times x plus 3, and I'm going to distribute that 2x, and I get 2x squared plus 6x. Now, factoring is the opposite of that. I look at both my terms, and I say, what can I take out of both of them? Well, both of them can be divided by a 2. 2 and 6 are divisible by 2. And an x. X squared and x are divisible by x. So what I do is I put my 2x on the outside, and I say to myself, quite simply, well, what is 2x squared divided by 2x? Well, that equals x. And what is 6x divided by 2x? Well, that equals 3. So that's how I get x plus 3 in the brackets. Now, in this case, 2x and x plus 3 are factors. And if you multiply them, they will equal 2x squared plus 6x. Okay, so they're inverse of each other. Now the greatest common factor, just like what we talked about greatest common factor last unit, it is the greatest coefficient that divides into all coefficient and any variables that are common to all terms. When choosing this variable, take the one with the smallest exponent. That's how you know the limits on the variable. Now, here's your steps. Determine the GCF of the coefficients, if possible. Determine the GCF of the variables, if possible. And what is the greatest amount of variables that can be factored or divided out of each term? Write the GCF outside a bracket and then divide each term by that GCF. Write the remaining terms inside the brackets. Now, you can check your work, and this is optional, by expanding, foiling, or this says binomial factors. Right now we're not dealing with those yet, but by expanding, distributing. I think this was a cut and paste from something else. Okay. Later when we do trinomials, we will use FOIL to check our work. Okay. So, for example, remove the GCF by dividing each term and writing the remainder in brackets. So, if I look at this expression here, 5x to the 4 minus 10x to the cube plus 35x squared. Now, all the terms have coefficients that can be divided by 5, right, the coefficient. And all of the terms have a common x squared as their variable. So the GCF is 5x squared. So we write 5x squared outside the brackets, and then we just divide each term by 5x squared. And that's what goes inside the brackets. Now, if I want to check my answer, I can expand to see if that works. So just to kind of walk through this, 5x to the 4th divided by 5x squared is x squared. Minus 10x cubed divided by 5x squared is negative 2x. And 35x squared divided by 5x squared is 7. Okay, now let's verify. Let's verify by expanding the left side, right? Okay, so here we are. We're going to distribute the 5x squared and see if we multiply that out, do we get back to the original equation? So 5x squared times x squared, yes, that works, check. 5x squared times negative 2x, we get negative 10x cubed, check. And then 5x squared times 7, we get 35x squared, so check. So it works. Woo! Yay! We'll have a little happy face there, okay? So don't forget to check if you're not sure. Let's do some practice because that's how we learn. So let's look at this. Here we're just finding the GCF. So I have 2x plus 4. The GCF, the largest number I can take out of both of those terms is 2. 3x squared plus 9x. Well, for my GCF, it's going to be a 3 because I can take a 3 out of both 3 and 9. And then the largest variable I can take out of both is just an x. I can't take an x squared out of both because the 9x doesn't have a square. Here, I have 3 terms, so let's look at the number first. 12, 8, and 24, so the largest number I can take out of them is 4. And then I have an x squared, an x, and nothing. So 4 is actually our GCF because I don't have a variable in the 24, so I can't take one out. Next one, GCF, 12, 8, and 24. Well, I just learned that that would be a 4. Now let's look. For my x's, I have x cubed, x squared, and an x. So x, because that's the smallest one. I have a y, and a y. So a y. And I have a z and a z, but none there. So I don't have a z in all terms, so my GCF would be 4xy. All right. let's factor each binomials by pulling out the GCF of both terms. So here, my GCF of 6n and 9 is 3. 6n divided by 3 is 2n, and 9 divided by 3 is 3. Okay, and there we have it. 4c cubed plus 6c. So 4 and a 6, the largest number I can take out is a 2. C cubed and c, the largest variable I can take out is c. So 4c cubed divided by 2c is 2c squared. And 6c divided by 2c is 3. All right, if you want to check it by distributing, you sure can. I trust myself. Okay. All righty. Now here we have negative 3g plus 6. And I'm going to take out a negative 3 because I don't want to have my leading coefficient within the bracket to be negative. Okay? So, and I can't take a variable out of each of them, but I can take a negative 3 out. So here I would get g minus 2. So 6 divided by negative 3 is negative 2. But the big reason I do that is because I don't want a negative in the brackets at the beginning. Okay, and I think it's going to happen for the next one too. So if I look at the next one, I have negative 12d squared plus 8d. Well, I don't want to have a negative inside the bracket leading, so I'm going to divide by a negative, and the largest number there is a 4. 12 and 8 would be a 4. And then I have a d in both. So negative 12d squared divided by negative 4d is 3d. And then 8d divided by negative 4d would be negative 2. Okay, so again, I don't want a negative in the brackets in the beginning. Okay, now we're going to factor the following trinomials by pulling out the greatest common factor. So I have 5 minus 10z minus 5z squared. So my largest common factor. First, though, I want to put it in the right order. 5z squared, negative 5z squared, minus 10z plus 5. Okay? Now, because it's a different picture, I'm going to take out a negative 5 from each one. So I'll get z squared plus 2z minus 1. Okay? Our next factoring, we're going to factor trinomials, and we would do something with this, but for right now, we're just worrying about the common factors. I'm just going to put little bars on my z's because otherwise they look like 2's. Okay? Looking at the next one. It's in the right order, so I don't have to monkey around with that. I have 18, 12, and 6, so I can take a 6 out, but that's it. So 3z squared minus 4z plus 1. Okay. And here, they're not exactly in the right order, so let's rearrange. Okay. So I always want the largest power first, so negative 16x squared y squared. Is that right? No, I actually can leave the 12 there. We're going to go by what the highest on the x is. So negative 12x to the 3y minus 16x squared y squared, and then minus 20xy squared. So for my largest, I've got negative 12, negative 16, and negative 20. So I'm going to take out a negative 4. The limiting factor on my x is just an x, because this the negative 20xy squared has no exponents. And the limiting factor on my y is the first term with just a y. So negative 12 x cubed y divided by negative 4xy would be 3x squared. And then negative 16x squared y squared divided by negative 4xy would be plus 4 4xy. And then the last term, negative 20xy squared divided by negative 4xy would be plus 5. And all I have left is a y. Okay? So you see why when you take that negative out, it makes it nice and pretty inside the brackets. Okay. All right. Do we need to rearrange this one? No, I think we're good because the c's go down. So I have negative 20, negative 30, and negative 25. Lots of negative signs. So negative 5. Limiting factor on my c is the 1, and limiting factor on the d is the 1. So for the first term, negative 20, c to the 4d divided by negative 5 cd is 4 c to the 3. Then we get plus negative 30 divided by negative 5 is 6. C cubed divided by c is c squared. And d squared divided by d is d. And then negative 25 divided by negative 5 is plus 5. And cd factors out. So that was this. Now sometimes we might get a binomial GCF. If we look at these two, y plus 1 and y plus 1 is a factor of both those terms. So we can divide out the y plus 1. X divided by y plus 1 is x, or like this whole term. And then the other term would be plus 4. You have to keep this in brackets. And put that in brackets to keep it together. Okay, so be careful with those. All right, one last problem in this lesson. So here, a plus b and a plus b are factors of both of those. So we're going to factor that out, a plus b, and then we'll put the remainder, the 2x and the 3y here. 2x plus 3y. Now, you can, this one's harder to check. You could check by expanding and then also expanding and seeing if you get the same answer. But we're going to do something with trinomials later. This is technically a precursor to something we call factoring by grouping. Okay, so you got some practice to do. That's greatest common factoring, and it is just the reverse of, what am I trying to